Hello, Algebra 1 Common Core students from around New York State. By the way, if you want me to speak German, I can, but not very well. Not very well. Mein Name ist Mr. Herr Key. Herr Antwort. All right, whatever. My name is Mr. Krause. I'm going to call myself Mr. Key for today. Part 1, we are doing problems 13 through 24. All of this stuff can be neatly found on my website. I go through this, try to go through this now every time. There's my website. Just go to mrkrausemath.com. It's pretty easy to find. And then you go along the top here. Gosh, I love Dunkin' Donuts coffee. And you hit on Algebra 2 Common Core, Algebra 1 Common Core. Don't do Algebra 2. And here are all of the stuff you're going to need. The test, the multiple choice answers, and the video solutions for all of this stuff. And it's nice and neatly organized. One-stop shopping. Let me get rid of that. Let's get rocking and rolling. I have no idea. Page 5. Ooh, wow. Got lucky. All right, here we go. Table below shows the cost of mailing a postcard in different years. During which time interval did the cost increase the greatest? Let's see. This went up 5 over... That's like 100 years. That's not going to be it. This went up 8 over... what was that, 14 years? That's not bad. So 8 over 14. Remember, it's changing y. These are the y's. This is the x's. Changing y over changing x. 8 over 14. That's not bad. That's a lot better than this one. This one went up 10 in... Ooh, that's a lot. 21 years. So 10 over 21. This one's a little bit bigger than a half. This one's less than a half. So that's so far 8 over 14 is the winner. And this is 11 years, and it went up over 6. Oh, this is almost 2. This is almost 2. This is much, much bigger. This is the biggest average rate of change. I'm just trying to find the slope. What I'm doing is just finding slope between the two. All right, done with that. All right, we're done with that problem. We want to solve this by completing a square. So the first thing we're going to do is take x squared minus 8x plus square equals, I know it's a rectangle, and we're going to bring the 7 over to the other side. So equals positive 7 plus square. Now in these parentheses goes half of negative 8, so that's negative 4, and then we square it. And when you square negative 4, you get positive 16, but if I put 16 there, I got to put 16 over there. So I know it's got to be, and this is 23 when I add these two up. There's your answer, chillin'. Let's see, that's 13, 14. Every 4 I'm going to pause because I've been having problems with my audio. Let's see. A construction company uses f of p, where p is the number of people. P is also the domain. When you have f of p, this thing is the same as y, but the p is the x value, because normally you're used to see it like this, right? Excuse me. F of x. So reasonable domain. So f of p is the range, x is the domain. Well, we don't have an x in this case. P is the domain. So what they're saying is, what is a reasonable set of numbers for this domain, okay, of people? Positive integers. That means positive values that are not decimals. That looks pretty good. Positive real numbers. I don't think we can have 8.2 people. Positive and negatives. Can't have negative people. Both positive can't have negative people. So the answer is positive integers. That should have been a relatively straightforward problem, kids. All right, moving on. The easiest way to handle this is, quite frankly, just to go over to the calculator and check these. But I'm going to get rid of a couple of them. 3 times 0, remember we're plugging these in. 3 times 0 is not 1. 0 plus 3 is not 1. Negative 0 cubed is not 1. 3 to the 0 power is in fact 1. 3 to the 1 power is in fact 3. 3 squared is in fact 9. And 3 cubed is in fact 27. But like I said, the easiest way to do is to come over here, graph it. If that's what you think is the right answer, graph 3 raised to the, 3 raised to the x, and say, okay, there it is, but go to the table, Control T, and look, 0 is 1. Oh, those are decimals, but 0 is 1, and it shows you right there that's the answer. So it's an exponential function. So we did 12, 13, wait, what number was that? 13, 14, 15. Was that 16? Oh, got to take a break. All right, I'll be back. You probably didn't even know I was gone, huh? Yeah, you could have gotten a cup of coffee. Don't know. I was gone for about a minute or two. Given the functions this and this, which value of x makes them equal? Well, I'm going to do this 2 ways. I'm going to plug and chug. I usually try to start with the last one and see if it works. So if I take 1/2 of -6 and add 3, half of -6 is -3. I add 3, I get 0. And what's the absolute value of -6? It ain't 0. Half of 3 is a decimal. And half of 3 is 1. So 1/2 times 3 is 1.5 plus 3 is 4.5. It ain't 3. 2, half of 2. Half of 2 is equal to 1 plus 3. That's equal to 4. And the absolute value of 2 is not 2, not 4. So here's the answer. Now, I want to check this value. So I'm going to graph both of these. Control T, tab, the up arrow. Trying to do this the easy way, it didn't work out. Okay, so 1 divided by 2, x plus 3. Boom. And then we had the tab, the absolute value of x. Bam. So when do they equal each other? Well, if I go into menu and I go into analyze graph and I go into 4 intersection. So let me go into analyze graph 6, escape, 6, 4. It's easier that way. And I say, okay, this might. All right, there it is. Oh man, sorry. If you did it, you'd find out they're equal. That's the answer, -2. Using the tablet, and see, I can't even come back to my computer right. Using the tablet and the graphing calculator is not the most fun. I got to remember to use my mouse. All right, kids. Which is recursively function represents the sequence below? So these are all the same. So these are not going to help us out. So it's saying the second term, n plus 1 just means the second or the third or the fourth term, is equal to the one before. Oh my God, is that, I think what they're writing there is 2 to the fn. Boy, that was an awful, awful written test. They should be not, that's not good. I hope it didn't look like that on the day of the test. That is not good. Plus 3. So 2 cubed is 8, plus 3 is not 7. 2 cubed is 8, minus 1 is 7. So that one would work. So 2 cubed minus 1 is in fact 7. But we got to go again. Now we got to go 2 to the 7th minus 1 is that 15. And 2 to the 7th is like 256 or something like that. So that's not it. Luckily, those weren't the right answer. 2 times 3 plus 1, that's 7. And then 2 times 7 plus 1, that's 15. And then 2 times 15 plus 1, that's 31. So there it is. Let me show you how to do recursive on the calculator. It's kind of cool, actually. So we'll go into calculator mode, and I'm just going to type in 3 because that's my first value. Now that's stored in answer. So anytime I click on answer, it's 3. So now what I'm going to do now is still have answer in there. Oops. No, I don't have answer. I cleared it. So let me delete. 3, enter. Do that, 3. Now the one I said was 2 times answer. I should have probably put times. 2 times answer plus 1, enter. 7, enter. 15, enter. 31, enter. 63, was that the next one? Oh, they didn't show us. All right, that's it. Moving on, 19. The range of this function is, now range is the y values. So it's not bad. It says the range has to be, this one's probably, unless you've really studied exponential functions, this one's probably easiest to look at graphically. So we'll come over here and we'll look at this graphically, and you'll type in 5 raised to the x. And I hope you see that, I don't care, it's hard to see, but this line, this exponential line, never, ever, ever goes below. I don't care how far you go out here, it never goes below the x-axis. And if I go to the table, Control T, what you'll find out is as we go negative, those numbers get small, but they never go to 0. So the answer is y is greater than 0. Exponential functions, unless they have a vertical transformation, will never ever cross the x-axis. It is an asymptote. And I hope those are vocabulary words that your teachers taught you, that exponential functions always go down and then they approach 0, but they do not cross it. All right, last one. Well, for now. So the graph of this function is shown below. All right, so you need to know what these things mean. X plus 1 inside the parentheses is a shift to the right or a shift to the left. And this one you want to remember is backwards from what you normally would think. So because it's a plus 1, we're going to go left 1. Now, we also have a minus 2 on the outside. The minus 2 on the outside tells us we're either going to go up or down normal, what you normally would think. So because this is minus, we're going to go down 2. Now, I'm not even going to look at the answers. What I'm going to do is concentrate. I'm going to concentrate on just this right here. And I'm going to move all these points. Left 1, down 2. Left 1, down 2. Left 1, down 2. Left 1, down 2. And this is my new graph. So I want to pick the one that looks like this, and I believe it's choice 1. Yep, choice 1 right here. There it is. That's the easiest way to handle that one. All right, I'll be back. Every time I take a break, I take some Dunkin' Donuts coffee, my sponsor. By the way, Dunkin' Donuts is in fact sponsoring me. They've given me exactly nothing but delicious coffee. So they sponsor me with energy sponsors, and I'm not able to do that. Let's do this. All right, we're back. Wait, I think that problem's over with. I got to go to the next page. I got to go to the next page anyway. So we'll go to page 8. We got 4 problems left on these multiple choice, kids. How you doing? Are you kicking butt? I hope so. So which pair of equations cannot be used to solve the following systems of equations? So what they're doing now on these problems is they're going to try to change or manipulate the equations so we can use the elimination method. If you remember, the elimination method is if I have 4x and negative 4x. If I add those, they eliminate each other. There's nothing. Gone. And if I had 2y and negative 2y, they eliminate each other. So the elimination method says try to get the x's to match each other or the y's to match each other. So let's see how they changed the equations. This one did not change, so that one's okay. This one changed. Notice right here we have a pair of additive inverses or opposites, right? We have opposites. So if I added those y's would cancel. And that's okay, but how did they do that? Oh, they took this equation and they multiplied by negative 1. Both sides by negative 1. So this became a positive, this became positive, this became negative, and this became positive. That's legal. That's legal. We want the one that's not. So that one's fine. Again, this equation hasn't changed. But they took the second equation and notice again right here I have a pair of additive inverses or opposites. Those are that use the elimination method, and it looks like they multiplied the second equation by 2. Let's see if they did it correctly. Times 2, and times 2. So this one's fine. We've changed the first equation. We've now changed the first equation, and we are going to multiply that by, let's see, 4 times 3 would be 12. 2 times 3 would be 6. And 22 times 3 would be 66. So that first equation looks okay. Now here's what they did. They want these to be our additive inverses, these two right here. So they multiplied this by -3 to get that. Then they multiplied this by -3 to get that. And they multiplied 8 by -3 to get that. This one's fine. Check. It must be this one. So let's get rid of everything and see what the heck's wrong with this one. The first equation looks like the first equation got multiplied by 2. So we multiplied by 2 to get that equation. Okay. And the second equation, here's our additive inverses. We're going to multiply this one by 4. So we're multiplying by 4. So by 4, by 4, by 4, by 4. -8 times 4 is not -8. And there's the stinking problem right there. So this is number 4 is your answer. Woo! Okay, that wasn't too bad. Got a little weird. The graph representing a function below. Which function has a minimum less than the one shown? Let's see. We got to figure out what the minimum here is. 1, 2, 3, 4, 5, 6, 7. -7 is our minimum. So we need one of these that will have a minimum less than 7. Well, these are in vertex form. The vertex here is -3, -6. So the minimum here is -6. Here the vertex is +8, -2. The minimum here is -2. So these don't make any sense. And then we've got to graph these two. We've got to graph these two. Now, the other thing you could do is put these in vertex form. This would be x minus 3 squared. Remember, we're going to do half of that. But we're adding 9, so we got to subtract 9. So plus 7 minus 9. This would be -2. So my vertex here would be +3, -2. And this one would actually be x minus 1 squared. Since I added 1, I have to subtract 1. This would be -11. That would be our minimum there. So, whatever. The answer is 3. So, let me show you how to do this graphically. So, I'm going to put all of these on here graphically. Nope. And let's go to graph mode. So, the first one we're going to graph is x squared minus 6x. So, x squared minus 6x plus 7. Plus 7. Graph. Next one is x squared minus 2x. So x squared minus 2x minus 10. Oops, tab. Didn't tab. X squared minus 2x minus 10. All right, so the red one has a much lower minimum. If you'll notice, it's down here somewhere. So right now, the red one's winning. Now we got to do the other two. Absolute value of x plus 3. So we'll go in here. We'll hit tab. Boom. Boom shakalaka. Tab. Doesn't like that. Hit this. Here we go again. Try this again. All right, let's go here. Let's do this. I don't know why I'm not using my mouse. I should be using my mouse. Let me use my mouse because I don't have any problems then. So x, I don't have my mouse with me, plus 3. I could use the keypad or the touchpad. Forgot minus 6. Minus 6. Enter. Red one's still the lowest, so that's the one that's going to have the minimum. And then if we do the last one, tab, think, x minus 8. It was a plus 8. Doesn't really matter. Out here, plus 2. This actually goes up. That's that pink one. So the lowest one is red, and that's the one. That's the one that wins. Red's the big winner. All right, 2 left, kids. 2 left. Ding, 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 ding. Grisham. What a name. That's what I like. Grisham. John Grisham. Considering 3 situations. For the first 28 days, a sunflower grows at 3.5 per day. Now, per means we're going to multiply by x. The value of a car depreciates at a rate of 15%. And the amount of bacteria in a culture triples every 2 days. Triples. You should recognize from your graph that these two right here are exponential. They are not consistent. 15%. If you took 15% of 100 and you multiply by 15%, 0.15, you'd get, and you subtract, you'd get 85. And then if you took 15% of that, it would be a smaller number. And then if you took 15% of that, it would be a smaller number. If you triple something, if I take a number like 4 and I triple it, I get 12. And then I triple that, I get 36. And if I triple that, I get 108. And if I triple that, I get 324. Notice the difference is it's just getting bigger and bigger. So which statement describes a situation with equal difference? And that would be a linear one. And the only one that's linear is this one up here. One only. All right, kids, we're almost done. After performing an analysis on a set of data, Jackie examined the scatter plot of the residual values of the analysis. Which scatter plot indicates the best line of fit? All right, kids, so what you want is for the residuals to be at a minimum. You do not want patterns. Patterns indicate that a linear is not good. So that one's no good. That one has a pattern. This one has a somewhat pattern. This one also has a somewhat pattern. But you're also looking for residuals that are kind of small and scattered like this, up and down. You don't want them up like this, down up here and down way down here, because that means they're all over the place. But you want these residuals to be small. And so that's why choice 3 is the right answer. And we are done. Hit the subscribe button, hit the like button, comment me if you want, whatever. See you guys. Catch you on the flip side.